Welcome at the video for hypothesis testing. Last video we treated the data preparation. This video we move on to testing of hypotheses. I will primarily focus on the SPSS syntax, but I will also show you how to find these commands using the SPSS interface. So what we will treat today is the test of the mean, where I will discuss the null hypothesis, the standard deviation and the standard error, and the confidence interval. Additionally, I will also show the same philosophy in testing a correlation and testing a difference in means. So how do we test the mean? In order to use frequentist hypothesis testing, you have to be very certain about what the hypothesis is that you are testing. Now, usually you test a null hypothesis. The null hypothesis is either rejected or accepted based on the test. Now, in this case, the null hypothesis is formulated as follows. The mean is 0. If you can reject the null hypothesis, you could say that you can accept the alternative hypothesis, which is that the mean is not 0. There are some assumptions to the one-sample t-test. So first, there is an interval. The variable needs to be measured at the interval or ratio level, meaning that at the interval level, it has equal distances between the categories. So for instance, a thermometer, so the temperature, Celsius or Fahrenheit, they have equal intervals. Now, a ratio level variable has a meaningful 0 point. With temperature, this is not the case. 0 temperature does not mean there is no temperature. However, with money, for instance, €0 mean that you have absolutely no money. So the second assumption is that there are independent observations. Now, what does this mean? It means that the value for one person does not affect the value for another. In some cases, this assumption is violated. So, for instance, if you would interview all the members of one family, it is highly likely that some of the questions will be answered similarly by the family members. So these observations within this family are dependent on each other. Now, the third assumption is that there are no outliers. This is a tricky assumption because there are no straight rules of what is an outlier and what is not. However, the t-test, the variance, as well as the mean and the t-value can be influenced if there are extreme outliers in the data. The fourth assumption is whether the variable is approximately normally distributed. So how do you test the assumptions? Well, the descriptors can be can test whether the distribution is approximately normal. How do we do that? We ask for the statistics, stats, and we want to have the kurtosis, the skewness. Kurtosis says something about the peak of the normal distribution, and the skewness says something about whether it's more heavy on the right or the left tail. And we ask for the mean and the standard deviation. Now, as you can see, the mean is 4, standard deviation 1.8. The skewness is significant, since if you divide the statistics by the standard error, you get a value higher than 1.96. The kurtosis is not significant. So to be certain whether this skewness really makes creates a big problem, we will look at the QQ plot. You can ask a QQ plot by PP plot. And if it is normally distributed, you will find a linear pattern, which you have actually in this case. It's a little bit tilted at the end, towards the end, so it means it's skewed over there. However, we say that the variable is approximately normally distributed. So we can move on to the t-test. So we want to test the variable x for 7, and the test value is 0. As you can see here in this table, is that we test the mean is 4 with a standard deviation of 1.8, standard error of mean 0.06. The t-value is 65, which is really a large value, and therefore it's highly significant. Here's the formula of the one sample t-test. As you can see, the t-value is calculated by dividing the difference between the sample mean and population mean divided by the standard error. The standard error is based on the sample variance. Now, here I denoted two formulas, one of the sample variance and one of the population variance. As you can see, the formula is very similar, however, the letters are differently noted. So here the sample mean is, as we know, the X with a stripe on top. However, the population mean is denoted as mu. So how do we calculate it? Actually, you just take the differences between each observation and its mean of the sample and multiply and square these differences and sum them. Then divide it by the sample number of participants minus 1. Now for the population, this is very similar. As you can see, it denotes the variance. How much do people divert from the sample mean in this sample? The standard deviation is based on the variance measure. So as you can see, you take the square root of the variance to calculate standard deviation. The standard error, again, is also based on the standard deviation or the variance, but then corrected for this sample size, this particular sample. Now here we see them all together. As you can see, the variance is the most simplistic formula, where you just sum all the square differences and divide them by the sample size. With the standard deviation, you take the square root, and with the standard error, you not only take the square root, but you also divide it by the sample size. So the standard error tells you something about the sampling variance of your sample. Now, all of these measures of variance actually relate to this normal distribution. This is an assumption often made in statistics, and it has really nice properties. So, if you have a variable that is normally distributed, 95% of the cases would fall within 2 standard deviations of the mean. So, if you would draw a sample 100 times from the same population, 95% of these samples would lie around 2 standard deviations from the population mean. Now, this is actually what you need to test the null hypothesis. Again, remember, the null hypothesis states that the population mean is 0, and you want to know, based on your sample, whether this value actually, you can really accept that it is 0. Now, you want to know with a certain confidence whether you can accept or reject the null hypothesis. A very usual measure that is taken is the 95% confidence interval. So this confidence interval allows for a 5% error rate. A random sample means that each participant in the population has an equal chance of being selected in your sample. Now, based on this error rate, this 5% error rate, you can be confident about 95% lying around mu. So this line of reasoning of hypothesis testing can also be used for other situations. So now we will discuss how you will test the difference in means between two groups. So you divide your population or your sample into two groups, for instance male and female, and you want to test whether the means are different between these two groups. Now again, we have to formulate a null hypothesis as an alternative hypothesis. The null hypothesis means that the two means are equal, and hence the alternative hypothesis means that they are not equal. Now also, similarly to the one sample t-test, we have to make assumptions. Again, we have to assume that the variable is measured at the interval or ratio level, that we have independent observations, no outliers, and that each sample is approximately normally distributed. Additionally, we also have to assume that the standard deviations of the samples are equal, meaning that the distributions of these samples around the mean are relatively similar. And lastly, we also assume that the samples are randomly drawn independent of each other. Again, we type t-test group, which is the group variable. In my case, I will test whether the income is different between men and women. The variable again is x047, and here we have the tables in the output window. So the males, there are 445 males, 487 women, and the means are 4.02 and a 4.00. So you can already see they lie very closely together. So here's the Levene's test for equality of variances, where we test the standard deviations differ between men and women. And here is well, as you can see, it's not significant, so we can assume that the standard deviations between men and women are equal. Here we calculated the t-value, and the significance is higher than 0.05. By testing correlation, we want to see whether two variables are related to each other. We test the null hypothesis that correlation is zero, meaning that the two variables have nothing in common. If we can reject this null hypothesis, we can accept the alternative hypothesis that the correlation is not zero. Now, the correlation test of the correlation coefficient also is based on assumptions. Now, usually with the correlation coefficients, we refer to the Pearson product moment correlation. With this specific coefficient, we make the assumption that, again, the variable is measured at the interval or ratio level, that it approximately normally distributed, that the relationship is linear, that there are no outliers, and that there exists homoscedasticity. Now, this last assumption we will discuss in the video on regression analysis. Let's go to SPSS to see how we can conduct this test. I will test the correlation between income and education. Now, as you can see, they are positively related. The correlation coefficient is 0.5, meaning if you go up one scale of income, you will get a 0.5 higher unit on the educational level. And it is significant, which means that we can reject the null hypothesis. This means that in the population, most likely the correlation between education and income would not be zero. Up to now, we only considered two-sided tests. So, for instance, with the correlation, correlation can either be negative or positive in the alternative hypothesis. Now, you could also formulate one-sided test. In significance testing, usually with the two-tailed test, you divide the 5% error rate on both sides of the bell-shaped curve. However, with the one-tailed test, you just put the entire 5% error rate at one side of the curve, depending on whether you formulate it as positively or negatively, the null hypothesis. In contrast to a two-sided hypothesis, where you just test whether the difference between means is zero, in a one-sided hypothesis you will test whether the mean in one group is higher or lower than the mean in the second group. Now, in this slide I formulated the hypothesis in such a way that the null hypothesis tests that the mean in the first group is smaller or equal to the mean in the second group. If you will reject this null hypothesis, you can accept the alternative hypothesis where you say that the mean in the first group is higher than the mean in the second group. So a one-sided hypothesis with a correlation would be, for instance, you expect a positive correlation. This would mean that the null hypothesis is formulated as if the correlation is smaller than or equal than to 0. With this, I would like to end this presentation about hypothesis testing. The next video will continue hypothesis testing, but then with a cross tabulation.